participants, and guests. It is with immense pleasure that I welcome you all to the inaugural ceremony of Faculty Development Program on Machine Learning Basic to Beyond, organized under the aegis of E&ICT Academy. Myself, Dr. Surinder Hans, Faculty Course Coordinator, on behalf of the Electrical Department, MNIT Jaipur, I again welcome you all here in the 10 days of FTP program. So first of all, I am thankful to Chairman E&ICT Academy and Director of MNIT Jaipur, Professor N.P. Padi sir, Chief Investigator E&ICT, Professor Vinit Savla, Coordinator E&ICT Academy, Dr. Satya Sai Jagannath Nanda, Co-Chief Investigator E&ICT Academy, Professor Lav Bhargav, Professor Pili Subhakar, Dr. Ravi Kumar Madila, HOD Department of Electrical Engineering from Professor Nikhil Gupta sir. Without their effort, this FDP that would not be possible to start within this time frame. We are truly honored today by the presence of 9 distinguished experts who have graciously agreed to be part of this FDP. I extend my heartfelt gratitude to each of them for their invaluable time and commitment. Though time does not permit me to detail each profile fully, so allow me to give a brief snapshot of each and every expert. So first, uh, Honorable respected Professor Rajesh Kumar, Department of Human Anatomy and Physiology, University of Johannesburg, South Africa. He is also the coordinator of this FDP. Second expert with us, Dr. Chandresh, Department of Computer Science and Engineering, IIT Indore. Dr. Shaili Sachdeva, Department of Computer Science and Engineering, she is from NIT Delhi. Dr. Chandra Prakash, Department of Computer Science and Engineering, SVNIT Surat. Dr. Ankit Vijay Varghya, he is right now with us. He is from Dublin City University, Ireland. Dr. Anup Nandi, Department of Computer Science and Engineering, NIT Rourkela. Dr. Rishabh Singh, Department of Computer Science and Engineering, IIT Patna. Dr. Yogesh Kumar Meena, Department of Computer Science and Engineering, IIT Gandhinagar. Dr. Rahul Kala, Department of Information Technology, IITM Gwalior. And at the last, I am also the expert of this FDP, myself, Dr. Surinder Hans, Department of Electrical Engineering, MNIT Jaipur. So this faculty development program is scheduled from this 1st May today itself, and it will go to 10th May. Is designed to take us through this entire spectrum of machine learning, right from the fundamental concept, as the name of this FDP is machine learning basic to beyond. So that we will cover this advanced and this cutting edge applications. So this program, this reflect our aspiration to bridge the gap between the core theoretical knowledge and real world deployment of intelligent systems. So this machine learning, that as we know, this is not specific for this computer science branch. So anybody can learn this machine learning. So machine learning today is more than just a buzzword. It is reshaping industries, redefining research paradigms, and becoming an indispensable part of curriculum and innovations. So as faculty members, researchers, and academic leaders, it becomes our responsibility to not just understand this concept, but to enable the next generation with this knowledge. So in this FDP that we will explore the fundamental algorithm and statistical models, supervised and unsupervised learning methods. So all the various algorithms that are coming under the supervised and unsupervised machine learning, interpretability and model evaluation, and also real world case studies in area like healthcare, IoT, finance, and autonomous systems. So the goal is to ensure a blend of theory, hands-on practices, and forward-looking insights, equipping all the these participants with both the competence and confidence. So let me also take a moment to acknowledge the pivotal role of the EICT Academy, a joint initiative by the MIT Government of India in collaboration with the several IITs and NITs. Its mission is to enhance the skills of faculty and technical professionals in core and emerging area of electronics and ICT. This FDP is a part of this broader mission of this E&ICT Academy to foster academic excellence, research capability, and industry relevant skills across institutions. So we deeply appreciate the support and guidance received from Academy, without which this event that would not be possible. So the expectation and outcomes that from this FDP, the first, let me just uh, give 2 minutes on this one. So the participant, this I encourage all the participants to approach this program, this with curiosity, just to solve their query, their doubt, their research problem maybe, and they can also collaborate to interact with peers and faculty from across the country, and the commitment to apply this learning back in your teaching, research, and innovation efforts. So by the end of this FDP, uh, we hope you will not only gain conceptual clarity and practical skills, but also build meaningful academic and professional network that will support future collaboration and growth. So we are privileged to have with us uh, all the 9 different domain experts, so who are leader in machine learning, artificial intelligence, data science, and computational modeling. So the faculty, this expert that who have consulted with industry and government organizations, and their open source machine learning platform, also their academic curriculum design. So I also want to take this opportunity to appreciate the organizing committee. Special thanks to Mr. Ramesh, who have worked diligently over the past week to ensure this program is conducted smoothly. So whether it be making group formation, this sending the link, platform setup, all these things. So their silent this contribution are the backbone of this program success. So to conclude, I would like to say that learning is a lifelong journey. So the platform like these act as a powerful catalyst. Let this FDP be more than a certification course, and let it be a transformational experience, one more inspire new research, innovative teaching, and collaboration. So thank you all once again. So now I invite Professor Love Bhargav, Dean RNC, MNIT Jaipur, and he is also co-chief investigator E&ICT Academy. So now I hand over the session to Professor Love Bhargav. Sir.
Yeah. So the dignity is present on screen and off screen. And dear participants, welcome to this course. MNIT has been very active in organizing various FDPs and activities for students for their academic upliftment. And Professor Rajesh, he has joined from Johannesburg, our faculty. And welcome Dr. Ankit also. EICT Academy, as you know, as Surendra has said, it's a joint venture of MIT and MNIT Jaipur, and the performance has been very good. Our effort has been to organize quality courses for faculty, and as is evident from the list of experts in this particular course also, that the experts are very carefully chosen, that your experience should be one where you go with a sense of having achieved from something from this course. My best wishes for the course, and happy learning. Thank you.
Thank you, sir. So now I invite Professor Rajesh Kumar so to say few words about this FDP.
Yeah, so good morning to all of you. And it's very early from this side, but yeah, it's around 9:30 there. Uh, I'm thankful to my whole own institute, MNIT Jaipur, and the EICT Academy to approve this course. And this course is basically important in a way that it is we are starting from very fundamental. So it's a fundamental course over which you can build any kind of a machine learning or later on some kind of a advanced learning algorithm methodologies. So this course is that way it is very important, and yes, I can see the contents and the speakers. They are expertise of various domain. The contents are starting from statistical models and then slowly moving towards the advanced machine learning algorithms. We can also check it that most of the part is there on the hands-on, and that is the beauty of this AICT Academy courses, that the participants have a lot of experience of doing by their hand, and this is good in a way for the speakers also, because sometimes speakers they uh, do the mathematics, but when they participate along with the participants and do hands-on, uh, sometimes they get a new insight of over the methodology and the models which are available there. So as told by our dean also, Professor Love Bhargav, the EICT Academy of Jaipur is doing very excellent work in organizing a lot of courses. This course and then followed by some advanced machine learning courses are also there. So it will help you in connecting many more courses, because once we have fundamental aspects there, okay, we know the things. Right now we know what is linear regression, the most simplest model. But if you see the linear regression and if you listen the speaker, you will find more than 100 ways of doing the same problem, the same method, but the perspectives are different. Some people do it statistical way, some people approach the same thing using Bayesian approaches. Somebody do it by iterative way of doing the things. So there are various ways, but the ultimate is the simple linear regression. So this kind of courses will help us understanding the maybe the same algorithm, maybe the same data, but various approaches and various insights, and which later on give uh, help us to build a new or more advanced methodology and algorithms. So as told by the Dr. Surender, that this will also opens up a collaborative work. So here you can solve your problems, you can discuss your research problems, you can take away some new insight of the algorithm, and then you can collaborate with the among the participants or among the speakers here. You can have a good exposure or the collaborations or the availability of various people there who can help you in solving various kind of problems. So I'll wish that this course will be a great success for all of all of you in learning basically. And as recorded earlier also, I'll also wish you a happy learning. Thank you very much.
Thank you, sir. So now next I invite Dr. Ankit Vijayvargiya to say something about their upcoming session. Uh, he has three lab session today. First, 1 hour that will be in the first half, and 2 hour, next 2 hour that will be in the second half. So now I invite Dr. Ankit Vijayvargiya to say something about their session.
Thank you, Sendra sir. Am I audible?
Yes, perfectly.
Thank you. So, good morning, all of you. I'm truly delighted to welcome you, all the participants, to this exciting and enriching online FDP on machine learning, basic to beyond. So now these days, machine learning is rapidly transforming industries and research field, driving innovation through data, decision making, and intelligent automation. So understanding its core concept has become essential for the professional across the discipline, including educators and researchers. So to effectively understand and apply the machine learning, it is essential to begin with the right fundamental tool. And as all we know, Python programming is the one of the most powerful among them. So in this FDP, I will begin with the basic introduction to the Python, helping you build the essential programming foundation needed to explore and implement machine learning concept with the confidence. I hope this FDP will not only provide you with a theoretical understanding of machine learning, but also help you to develop hands-on skill that you can apply directly in your academic and professional work. So at the end, my best wishes to all of you. May this FDP empower you to push the boundaries of your knowledge, inspiring new ideas, and foster collaboration in the field of machine learning. So thank you, everyone. Thank you. Thank you all.
Thank you, Dr. Ankit. So now this is the right time to start the first session of this FDP Machine Learning Basic to Beyond. So now before start the first session of this FDP, let me introduce Professor Rajesh Kumar. So Professor Rajesh Kumar, Senior Member IEEE, Fellow IET, Fellow IE, Fellow IETE, Lifetime Member CSI, Lifetime Member ISTE, received the BTech degree in Honors Electrical Engineering from National Institute of Technology, Kurukshetra in 1994. The ME and PhD degree in Power Systems and Intelligent Systems from the Malvi National Institute of Technology, Jaipur in 1997 and 2005, respectively. He was a postdoctoral research fellow with the Department of Electrical and Computer Engineering, National University of Singapore from 2009 to 2011. Currently, he is working as a professor of artificial intelligence at the Department of Human Anatomy and Physiology, Faculty of Health Sciences, University of Johannesburg, South Africa, and a professor in the Department of Electrical Engineering, MNIT Jaipur. His research interests focus on intelligent systems, data-driven algorithms, analytics, and healthcare. He holds 18 patents and published over 750 research articles in international conferences and journals. He has supervised 28 PhD and more than 50 master students. He is the recipient of several academic best papers, best thesis, and professional awards. He has been felicitated with the Career Award for Young Teachers in 2002 from the Government of India. He has delivered more than 300 keynotes, expert talks in various conferences, faculty development programs, and workshops. He has been on the research boards of more than 30 universities across the world. He is also on the board of studies of 20 universities in India. He has also worked as an accreditation evaluator for NBA, NAC, and AICT. He is appointed as IEEE IAS Distinguished Lecturer 2024-25. He is Conference Chair SOCTA 2024 and Executive General Chair Maitri 2024. He was Conference Program Chair PADES 2018, General Co-Chair ICRAI 2018, IICPE 2018, ICPS 2019, Maitri 2023, He was the General Chair of PADES 2020, AISCC 2020, GCAIA 2020, PADES 2022, SOCTA 2023, TPC Chair ITEC India 2021, Technical Chair SOCTA 2023. He has been associated editor of IEEE Access, IEEE Industrial Electronics Technology News, Swarm and Evolutionary Computation, Elsewhere, IET Renewable and Power Generation, IET Power Electronics, International Journal of Bio-Inspired Computing, and CAI Transactions on Intelligent Technology, IET. He has been an IEEE counselor, MNIT student branch, founding faculty advisor, IEEE IAS student chapter at MNIT, honorary secretary, IET Rajasthan chapter, XCOM IEEE Delhi, PES, IAS, and vice chairman, IEEE Rajasthan subsection. Thank you, Professor Rajesh, to be here, to be part of this FDP. And thank you, sir. Thank you very much. So now I hand over the session to Professor Rajesh Kumar, sir.
Yeah. And Dr. Sundar, please just check it whether my screen is visible.
Yes, sir. Perfectly visible, sir.
Yeah,
Audio
okay.
and
Thank you very much. Thank you. Thanks a lot. And thank you for a very detailed introduction. So we start the first session with just a motivation of why machine learning, what are the applications, what are the opportunity. So what we do is we started with the just revising the things there, that what is actually machine learning, and then what are the different lacks of machine learnings, and then where people are using it, followed by some of the applications where we have implemented at our institute, NIT Jaipur, and I'll showcase some of the research work which my team and the people and the collaborators at MNIT, at Raman Lab, they have done it. So that will be the first session, just to start the things in a way that where and how we can implement machine learning, and just to revise the things there.
hello. Sorry to interrupt you, sir.
Yeah.
Your your video is not.
Okay. Let me check it. Second. It's still not visible.
No, sir. Earlier it was on, but now I cannot see.
Okay, let me check it, because when I shift to full screen, maybe because of that. Just I stop sharing and redo it.
Yes, sir. Now I can see.
Okay.
Yes, sir.
Is it okay now?
Yes, yes. Perfectly fine, sir.
Okay. Okay, so I'll take some of the references here. Like, this is one very nice article from Eskundu, and you can see some images are there. And this one is basically a image of a scan, and it is showing that there is no osteoarthritis in the next 3 years. And then another image, if you check it, Yeah, this one is creating a problem. This one is another image which is showing that there is osteoarthritis in next 3 years. I'm just taking the example of healthcare because it directly connected to our human body, and we take the things more seriously that way. But if you put these two images together, you can see that it's difficult, and then and difficult to identify the things in a immediately. Maybe sometimes even doctors, they are scanning these things, they don't have time, and there are sometimes possibilities that the diagnosis is not that much appropriate. But when we pass these images to your machine learning algorithms or AI algorithms, we can do a lot of things. And this is how AI can see it. So AI not only can predict it, like, okay, whether there is osteoarthritis in the 3 years or likewise, or there is no osteoarthritis. It can take this, it can talk about the whole spectrum, that if it is not there, if it is building, and then how it is progressing, so in a forward direction. And if some situation is given what is as on today, it can go back also, that what was the situation yesterday or day before yesterday or 10 years before or something like that. But that depends upon how much of the data available and then how accurate our models are. So then this is some kind of this is something which is very interesting, which AI or machine learning algorithms, they give us. The second example is basically another one very interesting work which was done on predictions. The work was done by Kosinski. So he was the person who worked a lot on the human modeling and behavior modeling and all these things. And his efforts later on brings if you go to this social media installations and all these things, so now they start, after that they start asking whether these things are permitted or not. So he and his team worked a lot on this one, and then in 2012 he came out with these kind of findings that, okay, you give me the 68 Facebook likes, and the model can predict the skin color with a 95 of accuracy. So may not be the skin color pictures you are passing the pictures of, you are passing the likes there, that the person or his profile is liked by how many people, or something is posted is liked by how many persons, and from there we are predicting something different which is not as such directly available there. Not only that, they did a lot of experiments. They worked on, like, okay, what about the sexual orientation with 88%, which party the people like, okay, what are their preferences, and you can do a lot only just by observing the number of the likes. You can find out the intelligence, religious affiliations, as well as, not only that, you can go for a person is alcoholic or not, drug usage, and many more things. And that is the power, and that's why this is becoming day by day very powerful technology. So this technology is transiting from one domain to another domain. The basic fundamental mathematics, which was developed very long back, and now we have very good and high computational power, and that computational power we use it to explore more of the relations and the interrelations between the inputs, and to check out what are the hidden signatures available there, and can we predict something more. So his work keep on improving. If you give more data, then you can see that what they can talk about. They are saying that you give us more data, you give us more likes. Not only we can tell about you, but we can tell about what your friends knew, or about your friends. You give more inputs, the models can talk about what their parents knew, and then what their partners knew, and likewise. So that is basically the structure there. And that is basically one kind of intelligence, and intelligence normally we also do. Like if you go to the uh, human understanding or human intelligence, there also what we do is we learn through the patterns. So we observe certain kind of patterns, we observe certain kind of relations between those patterns, and then we develop our some kind of understanding of those things there. So AI is basically how the intelligence is exhibited by the machines. So we know what is intelligence, and then how we can connect it in the mathematical form. If you go to the by the history of the things there, people started from very basic models, very simple way of categorizing the things, and then slowly they observe how the human brain works, and then one leg comes into it. Then they observe how the experience, through experience we get the things, the another leg is developed. Then they say that how we work in a group, the another leg appeared there. And then people observe that, okay, how we learn through the reward mechanism, the another leg come into these things. And this is how this whole scenario or whole ecosystem is being developed there. So the evolution of AI is something like that. Initially, we started with the reactive machines, so not much, they don't have that much of memories. They work based upon the current situations, and likewise, and like playing a chess game, if we are not using the memory, that is the part there. Then AI with limited memory, when we are talking about like, okay, we have some memory which is there, some past data is there, some experience are there, and from there we try to make certain kind of a decisions and all those things. So self-driving vehicles are one example of it. So we are here right now with AI with limited memory. And then we talk about the future there. And the future is the theory of mind. Can we implement how we can represent the whole world, how we can understand each other, how we can interact with each other, and that is the whole system is moving towards that. And what is expected later on is the self-awareness. Can we integrate consciousness or self-awareness, awareness of emotions? Can we anticipate reactions of others? And that is the zone where people are now moving towards there. So this whole this whole session is on, we talk about the introduction of machine learning because it's a part of it. AI is a big structure. We'll see how people get confused and what is this one. And then we talk about how it works. We discuss about some various classifications of this one, various sections of this one, some applications, and what can be the opportunities there. So the basic idea is how the human learn. There are various ways of understanding this one, but the simplest one is, okay, this is the challenge, this is the thing which make us understand in the easiest form. That okay, I'm there and there is a chili, and the question is, should I eat it? Now this is the decision I have to take it. Now this decision, there must be some kind of mechanism, because when I'm going to take this decision, I have certain things with me. Okay. So one thing, okay, somebody will suggest me who's there that this is red chilies are usually hot, so be careful. So some information is coming to me, which help me in taking a decision. And then some kind of another experience is there with me. The last time when I eat it, it was not that hot, and so last time when I ate it, it was not that hot, and I can go for it. So now we have certain kind of information to make my decision there. Now these are the two things which are very important. One, what somebody is suggesting me, so it's a data which is coming to me. Okay, these are usually hot or not hot. So this is the information which is coming to me. And another is the past experience. And over these two things, I make a certain kind of a decision. I connect these things through a certain kind of a certain kind of combinations, and then I can make a decision over there. And then based upon my experience, then I can update it, because that this experience will be the past experience for next decision making kind of a process there. So these things help us in making a decision, and that is how we learn the things. Because if I eat it for several times, or some kind of a different textures are there, I can make a list or I can memorize it in a way that if it is pure red, then it is hot. If it is less, it is less hot, or something like that. And this is how we use this kind of experience to develop these algorithms, and that is basically we talk about the machine learning. So AI is a big structure there. So AI is basically it's like we can read it here. It's the engineering of making intelligent machines and program, and machine learning, it is a subset of it. And now the deep learning is getting very popular, which is further subset of it, and likewise. So we need to understand this kind of a structure. Who is the subset of what? AI has so many different legs. Machine learning is basically one section of it, and then deep learning is basically a subsection of machine learning, where we particularly focus towards neural networks and likewise. So where is the difference? And where is the difference in simple programming? People have certain kind of a question that, okay, there is a program. Here also we are writing a program. Where is the difference? And because in program also, when we write a program, we write a program in some programming language. There also we use certain kind of stats there, and the same thing where we are doing it here. So where is the difference? And the difference is here. You can see here, if in traditional programming, what we do, we pass the data, those are the variables. Okay, x is 1 2 3 4 5, those are the variables, and then we write a equation there that y is equal to 2 times of x, and then it will give an answer to a and then we execute it. It will give us an output that, okay, the output will be 2 4 6 8 10, or likewise. In machine learning, what we are doing is the other way. We give the two inputs. One is the x, that is 1 2 3 4 5, and then we give the output. Okay, this is the output, that is 2 4 6 8 10. What we want is, you give us a logic. We want the computer to give us a logic, us a relation between the input and output, and that is basically, so it will give us y is equal to 2 of x. So now that there are two things there. One, the inputs are known to us, outputs are also known to us, but then we pass some kind of argument to my machine that, okay, what I'm looking for. And there are various ways of doing this one. Say I'm looking for a linear relation. So then I'll say, okay, y is equal to mx is my what I'm looking for. That is my hypothesis I'm putting for this kind of a data set. And then the job is to find out the m. And that m can be calculated various ways, statistically or iterative way of doing the thing. So many other ways are there. So what is the value of that particular m? So something it is, if you go check it other way, you can say, oh, it is same as a curve fitting. Yes, it can, you can take it that way. So calculating the m by an approach is basically you are training the model. And that is basically how this whole structure is working there. So we use it, and why it is getting popular? Because now we are full of data. There's large amount of data which are available, and there are various V's there. People call it, there are various V's. The volume is very large. There's a large variety of it. Variability is there. These V's cannot be analyzed manually as such, because I'm collecting a data, say healthcare data. So a person is visiting a hospital. So we have a data which are path data, we have physiological data, we have X-ray data, we have some signal data. So there is a variety in the data. And there are a lot of such samples there. If you take a hospital record of a month, you can see, you can just check it. Okay, if a person is say if 1,000 persons are visiting hospital per day, in a month it is 30,000. It's difficult to analyze that one. So we need some algorithms which can infer, which can correlate the things and give us some kind of important insights to solve a complex problem. Basically, there are three legs of machine learning. One is supervised, another one is unsupervised, and third one is reinforcement learning. Initially, people say that, okay, supervised and unsupervised, they are classical learning. Reinforcement learning is a bit, they put in a different category. But later on, you'll find that they are very much intermixed, and then people come out with another kind of a leg that is semi-supervised learning, and many more combinations are there. So what is the difference? What is there in supervised learning? In supervised learning, that means there is a supervisor who tell you that okay, whatever your outcome, what is your model is generating, is it correct or not? So that is the job of a supervisor. It will give you some kind of a corrections on tell you that okay, your findings are correct or it's not correct. That means how we can take it in algorithm part. Algorithm part, we can take it this way, that I know what is the output then. And if my model is giving some different output, I know what is the actual one, and the another one is what is the predicted one. I can check it, how much is the error. And then I work towards minimizing that error. And so how I can minimize my error? My model have only three things: hypothesis, input output is one set, hypothesis, and the parameters, model parameters. So I can minimize that error by playing with the parameters, and then come out that okay, this is the output which is the give the minimum error. So that means if I know the output and I use that output to modify my parameter values, that is supervised learning. That means my data are labeled. Labeled means that I know that for these X input, this is the Y out. In unsupervised learning, there is nothing, no labeling of the data. There is no supervisor. Then how we do it? We find out the similarity between the things. And from the similarity, we make the groups, we make the clusters. And then we check out on the clusters that, okay, this cluster belongs to this type of a category, then we can do further work on that. That is basically unsupervised. And the reinforcement learning is basically, it is learning by doing basically. So we act in the environment, and then environment, we take some actions in the environment returns us some rewards, and based upon the rewards we update ourselves. It is same as like, okay, initially say somebody tells you that how to play a chess game, but then you play more and more game, and then you modify your game. So every time you play, you take certain actions, you play with some strategy, you win, you'll get a reward, and then you update your things there. You lose, you'll get some negative reward, then you update yourself, enhance your knowledge. And if you follow this kind of learning, this is reinforcement learning, reward based learning there. And now these are the subclasses of this one. So when we do supervised learning, so in or almost everywhere, if you talk about machine learning, there are two types of, you can categorize the things into two, most of the algorithms into two categories. Either they are discriminative, sorry. So they discriminate the things. Okay, that okay, the output is A or output is B, or they are of the mode of regression or generative, we call it. So let's take it what it means. What the job machine learning algorithm will do. One job it can do is that okay, I give once the model is trained, I give new input and it give me the corresponding output. So it is generating the output. So that is one class. And the second category is I give input, it will give me the output that this is a spam, it's not a spam. This is healthy, not healthy. This is tumor, no tumor, or something like that. So that is basically discriminative. So regression is a part. Regression is basically giving a new value. Classification is we classify the things. In unsupervised learning, what we look for most, making the groups. So the clustering there, maybe we are looking for the association between the parameters, or we are looking for the reduction in the dimension that, okay, I have a large dimension, huge data, big data, can I reduce the dimension? Because many times it is observed that there are a lot of features, but many of those features are not that important. So how to reduce those things there? Then two more things added to this one. One is neural networks and deep learning. So this leg is basically this is developed totally towards how our brain processing works. So our brain is having neurons, how neurons work, how they are connected with each other, and that kind of arrangement, that kind of network, that kind of topologies are being used. Those are neural networks, and then we make these neural networks very big that will move towards the deep learning kind of stuff there. And another leg which developed is basically ensemble methods. Ensemble methods is a very nice domain, which is basically inspired from the theory that, okay, I have certain models which are simple models, but they are not very accurate one because my data pattern is a complex. So what I can do is I can use many simple models which are very fast in processing. We are very light models. So I use various combinations of these simple models to solve my complex problem. So the idea is break your big problem into small problems and solve it that way. So those are ensemble methods, and there are various ways of ensembling the two things there. And then we have the name of the methods, that is basically the approach there. So in classical, we have like KNN, we have naive Bayes, we have linear polynomial regression, we have support vector machines, we have decision trees. Then in classical, is basically both. Classical both here is supervised and unsupervised, I'm putting there. Then in deep learning, we have a category like it starts with MLP, then autoencoders, GAN, CNN, RNN, and then you can see a lot of updates are available on different versions of CNN, different versions of RNN, different versions of GNN likewise. In sample methods, we have boosting, we have bagging, and we have stacking there. Stacking means one over another. Bagging means use a bag topology, data put in, take out. Boosting means how you boost the performance. So there are various different methods are available for all these three legs there. In reinforcement learning, okay, we talk about Q learning, we talk about deep Q learning, SARSA, GA, and then PPO, policy-based algorithms, reinforced algorithms, and there are many more there. So this is how these algorithms, they can be categorized in different forms there. What are the softwares which people are using it? These are the common software people are using: Keras, TensorFlow, PyTorch. Okay, when we talk about Keras, TensorFlow, PyTorch, these are the available software, available packages which are available. Most of the most common software or programming language people are using is Python. People are using MATLAB also. People are doing it in through R also. People are doing even with Excel sheets also. They are using Excel sheet to solve as a machine learning Excel sheet to solve machine learning methods. But the most common are these one. So how to start with the ML? What are the basic things you need it to be a good ML machine learning expert? We need to learn few things there, and which we already know. We just to revise the things. Linear algebra, which we have done it at level 12 or high school, or in the first year of engineering. Probability, calculus, multivariate and univariate, and stats, and information theory. So these are the basic things which are required to develop machine learning algorithms. So suggestion here is just, if you want a very good ML expert, just revise these things, and then you can develop a new algorithms, and you will be expert in machine learning. Okay, so the focus on the algorithm and algorithms focus on the basic things, and those are the basic mathematics, which is of first year of engineering, or it's a high school mathematics there. So what is the way? Okay, choose a systematic process, and that's where when you talk about people who are working machine learning, they talk about the pipeline. So this is the pipeline. They talk about like this one. This one is basically a systematic way of doing the things. So what will be the flow? So choose a process, map the process, what are the best tools, and then understand the data set. That is most important. What most of the things most of the work which I have seen people are doing a lot, because a lot of these algorithms are already available. What is the biggest mistake they are doing it? They are taking the data, they are taking the algorithms which are already available and just implementing it. This is the wrong way of doing the things. The most important and the good way of doing the thing is, first you understand the data. Try to visualize some samples of it. Try to check it, that what is the pattern, how the data they look like. And once you have that idea, then yeah, questions I'll take later on. Okay, so once you have that particular idea, then you know that okay, these are the different methods of solving it, and then you choose a approach and implement over it. The applications are endless. There are applications, now let's check it, where people have already implemented, already devices are available, and you will find a lot of research work and publications, and those things have been already done. In science, I'm talking science means pure science. In agriculture, finance, medicine, bioinformatics, security, defense, security and defense you can put together also, crime management, image speech recognition, city planning, city management, robotics, traffic predictions, product suggestions, language translations. So you can see here the applications are huge. These are few of the things which are very popular, like weather prediction. You'll find a lot and lot of research in weather prediction. And still there are challenges. It's not it's still there are challenges. And now working towards that, how to address this kind of a challenge there. So we have already discussed this part, but let's understand which algorithm is people have, or which methodology is good for what kind of a problem, or commonly being used. Like regression, if you're talking about regression means, I told you, it's a getting a new value for a new input, what will be the new output. So you will find applications in forecasting, in the predictions, process optimizations, and if you're looking for new insight about the patterns. In classifications, you will find a lot of application medical diagnosis. Basically, most of the time in medical side, we go for this part only, whether the person is healthy or not healthy, tumor, no tumor, cancer, no cancer. Okay, so that is basically classification. You will find applications of classification. These are the classification problems like uh, crime management, crime done, not done, or something like that. Then image classifications, image cat or dog, it's a classification problem. Customer retention, customer will retain or not retain. Okay, so that is also a classification problem, but you can convert this classification problem to a regression kind of setup also there. You'll find people have modified these things there. Unsurprised, we already discussed these things, association, clustering, and all these things. Reinforcement learning, real-time decision making, robotics, most popularly used in robotics. But now this reinforcement learning is moving in all the zone. If you check your chat GPT, check it out, what is the background, what is that backend, which algorithm is working. So many algorithms which are now very popular algorithm methods are there. They are using reinforcement learning. So it's a real-time decision making, self-acquisition, and all those things are there. In unsupervised, we can say that like clustering is targeted marketing. That okay, let's make we have data. We make a group of data based upon the age, and then from there we select that okay, from the group of 18 to 25, what are the features, and then we target that particular age group to market our products. Or we can go for recommender systems. You can see recommender systems, they are very common. You can check it on the websites, various websites. You search for one product, there are recommenders that okay, those who this one is good or this one is 4-star and 5-star and likewise and all that. Based upon two things. One is the feedback from the people, the another one is the grouping and the relations there. You go to some purchase websites, you'll find that uh you are searching certain product and say some certain kind of a pen there, but at the bottom you'll find that those who have purchased this pen also purchased this pencil, also purchased this thing and all those things there. Even on the movie and all those things, you will find that the web pages open for you, open for somebody else. They have a different kind of arrangement because they observe this your patterns, and based upon that they develop the recommender systems and likewise. Dimensionality reduction basically is used to reduce the dimensions or to find out the important features through it. So few applications which are already done. I have put some links there that okay, healthcare. Now in healthcare we have various informations, not only that X-rays and things. We have a lot of data through wristband, wearable technologies. Okay, and then we can use these informations to relate the things. I'll show you a few of the case studies later on that how we can use this kind of arrangements to for disease diagnosis and early diagnostics and all that there. So healthcare, if I talk about, we have visualization, robotic assisted surgery, remote consultation, cybersecurity of data protection, hospital workflows, hospital management systems, and preliminary diagnostics, advanced image diagnostics, and many, many more. Some of the examples are already we have seen like in some different domain like epidemiology. We have seen the studies earlier, how these algorithms help us in controlling this one, because we have seen this one during the COVID, the trends and the flow, the patterns, and likewise, which help us in controlling the various kind of various like this deadly disease in 2019-20. We know how these things works. So this gives certain kind of information, what are the trends, what are the patterns, and then how to take, then you can take a preventive measures to control these things there. Traffic management is getting very fast. So this domain is developing very fast. Already developed countries, they have all these things set up there. We have cameras which can help us in doing a lot of things there. Can we predict the peak hours? Can we allocate emergency services? And can we identify the stolen vehicles or certain kind of traffic violations, and all automated? So a lot of applications in that domain also. Those are from electrical engineering. Smart grid is full of it. Weather predictions, because now we are relying on renewables. Demand management, load management, user behavior, generation side management, maintenance management. Lot of such applications are there where people are using machine learning approaches. Defense. Okay, so in defense, warfare platforms, cyber security, target recognition, automated systems, threat monitoring systems, all these are the zone where people have already implemented, and now then they are exploring the application into the new domain also. Agriculture, we can have challenges in and we have addressed it in the domain of like species identification, greenhouse management, big area. Lot of greenhouses are now developing all across the world. Weather prediction, crop disease treatment, farmer decision making, supporting system, mapping, estimating, mapping the yields and all that there. So this one is a reinforcement learning. This one I already explained you in a very compressed manner, that okay, robo is there and it has to take a decision, which side should I go, left or right. If I go to right and I take a decision to go to right. Okay, so yeah, I'll discuss on those things. There's nice question from some of the participant here. So it goes towards right and then it will touch the heat. The sensors say that it's very hot, so it will give negative reward to it. So negative reward means next time it will not go towards right, it will go towards left, and likewise. So this is the way it will learn, and lot of such kind of applications there in the control and the automation process in engineering there. There is another domain which is large scale machine. Basically, we have huge data, many methods there, variety of the data, and then we look for variety of outputs from there. Deep learning, I told you, you can see here in let me check if the pointer works there. Okay, you can see here, this one is a neural network, simple neural network in 1980s. And then you can see that now the network is deep into it. Yeah. So initially people start with the fatty network. That means this hidden layer is more hidden layer, but the length of the network is small. But now later on they realize now that they change the topology, and instead of making it fatty, they make it the lengthy network, and this is basically the deep neural network. Why they go for it? So the job is, okay, I give you an input here, say the image, and it has to identify whether it's a cat or dog or something like that. So the input here which I'm passing it, what I'll do is when I pass it, I'll pass the certain values in, we call it the features there. And based upon those features, we try to find out what is the output. But later on it was suggested that why we send the features. Let the network to find out the feature of its own. So we just give the input, and then these layers and their arrangement, these arrangements helps in finding the features and then identifying it. So that is basically the deep learning works there. And how it works, it totally depends upon what are the weights. Weights means how this node and this node is connected. If it is strongly connected, that means the weights are high. If it is weakly connected, that means the weights are less. And this arrangement of strong and weak connection make, understand, or memorize that patterns there. And how to make this strong and weak, that is basically known as the training of the algorithm. So this one is one part, and then typically breaking the image into sections and memorizing and identifying it. Another domain comes in, that is convolution neural network, and then if it is region-based, then region-based convolution, then one-dimensional convolution, two-dimensional convolution, and people are exploring this whole domain of deep learning. Robotics zone is full of the applications there, lot of applications in the robotics. Computer vision we have already seen. People have already implemented in augmented reality, 3D object recognition, games, inspection, identification, reconstruction, segmentation, panorama creations, and likewise. Another domain is NLP, natural language processing, and now you can see it's there in your mobile and everywhere. It converts from one language to another language, from sound, voice to text, text to voice, and then if we have words, then it can summarize the documents, it can identify the similarity between the documents, and likewise. All comes under this category of natural language processing. Internet of Things, because now most of the things they are connected through the internet. We have sensors, so we have a lot of data, and these data we can use to identify the or to identify the relations, interrelations, and predict the outputs there. Another domain which is parallel building, which is almost similar, but we need to understand that is neuromorphic computing. And you can see here, this is kind of a more towards a neural brain dynamics. So it started it's not new that what I told you, it started somewhere in 1940s, you can see there. But later on, later on, a parallel area developed there. So you can see that first neural network, artificial neural network model comes in 1943, and then this leg keep on working. It works on the kind of a topologies and the arrangement there. The another leg which works on the statistical machine, which has become very popular with descent trees and all that in 1966. And the third leg, which is basically more in the dynamic machine learning, which is reinforcement and all that zone, and that is basically 1961. So most of the work is done in the zone. Mathematical work was done in 50s to 60s, and then modifications come later on, how these networks are connected, which type of mathematics we used, and then the combination of those things there. Some applications, Go games. Now you can understand the complexity. This is a very complex game, but it is you can go and check out the literature, and then you can check out some videos are also available, how a computer beat the champion in the Go game there. Chess, a lot of examples are there, and these are the various approaches people have developed to play chess. AI-based chess, that is, these are certain methods there. These are the dedicated, then later on they develop the hardware and software combinations there. This we have already discussed, that what are the various applications there. So I'm just skipping there, but this is very important. Now this one is becoming a very common in governance also. So and you'll find in future governance, decision making, and automated systems, you'll find a lot of applications of AI. Coming to the last part of it, I think we are towards the end of the session. So this one is some of the work which we have done here. This one is one part of it is basically in the healthcare side. This one is conceptual picture, not the real one. So here the brain signals are taken. These are the sensors which are placed at the surface of the head. It's not insertive. They are surface mounted sensors. And these signals are captured there, and then signals from there we have controlled some robots. So the object is try to infer what is the thought process going in. Not only that, some work is being done in medical side, that like this was done very long back. So from the signals are captured. So the job here is some questionnaires are given to the subjects. We ask them to fill the answers there, and at the same time we recorded these signals, and then we pass those questions to the experts, medical experts, and the process these signals and able to identify the IQ level of a person. So we were able to make the group of high IQ people and low IQ people, and it has a lot of applications. This one is one part of it, but lot of, like, now you can see the applications in the domain, like where people are suffering from ADHD or suffering from Alzheimer, suffering from other domain. Now scientists, they are trying to find out the solutions through images, through the signals, and likewise. So this one is one area, one work which we have done. This one is another one which we have done with let me check it whether it will work or not. Cannot show you the live one. Just one second. Okay, this one is video is not working, but this one is towards the seizure detection. Exoskeleton we have done. So what we have done is, I think, yeah, Dr. Ankit is also here. He has completed his PhD on the same zone. So we have measured the signals, muscle signals, muscle activities, and then use machine learning algorithms to identify what is the muscle strength and what is the job we are looking for it, and then power it to some processing units, and then some support system there. So you can see one example here on the screen, that the sensor is placed near the wristwatch. It senses the muscle activity there, and the signal goes here, the processing unit, which power up the motors here, and that there is a gearing mechanism which support or which give the further power to this supportive system to support the hand there. Various applications are there. It can be used for stroke rehabilitation. It can be used as a supportive mechanism for amputee, or you can modify this one. It can be used as a supportive system, those who lose, the people who lose who lost the hand power or muscle power by any of the disease or any kind of incident. So this can be used at all those places there. This one is another one which is a gait analysis. So the another speaker who will maybe maybe he will discuss with you, but this is the one case, one interesting study, that is basically our gait has some kind of information. Gait means the how we walk, how we move, basically that is the gait. And the way we move or walk, it has a lot of information. So we have this this is the setup there, 4 cameras from different angles, and we capture the video. Video is converted into the frames, and then frame are pre-processed. So please make it a note. Pre-processing is very important when you are going for machine learning algorithm, to remove many of the unwanted things there, because if you send a wrong thing to your model, the model will be weak. So pre-processing, and from the pre-processing you can see here later the signatures are generated. Now these signatures have information. These signatures are of a different points there. You can do a lot with this one. You can identify whether a person is diabetic or not from these signatures. That is something interesting. You can find the mental state. You can find the hearing issues. from the signatures. A lot of health associated issues you can identify from the gait kinetics. Lot of application not only in this zone but also in the sports also. I don't know all these videos why they are not working. I want to show you, but yeah, now this will work. So you can see this video here. This one is just one live example, a recorded one, that now the person is recording the video of a person, video of a subject here. This was developed long back, and this is used to generate the signature. So to generate a signature is not AI. So you can see here, this is lab setup, and the background is you can see a lot of things there. Gate is there, some banners are there. So we are not kept the background very plain background, and you can see all these you can see the signals, they are blank because nobody is there. These are trunk angle, hip angle, knee angle, ankle angle, and likewise. And then when a person enter into the frame, just you watch it carefully. Now the person is entering the frame. You can see the coordinates are automatically generated at various points, and at the lower side you can see various signals are being generated. So these are the gate signature signals. So here when you're working on this one, okay, let's check the video first, and then you can click at any of the point. You will get the information that, okay, what is the posture of a person, what are the coordinates, and if there is an issue, you just click over it. A gate expert can easily identify what are the issues and what are the things there. But you can use machine learning also to identify issues and all these things there. So this one is another work which we have done. We are the first one who created Indian gate data, and now it is available. People are using that gate data for their research work. If you are interested, you can just write to us. We will send you the data there. This is another work which is basically towards the arthritis. So what happen is, basically you can see that people go for, if they are having a pain at the knee, they go for x-rays, and then x-rays give us some information. But many times it is observed that, and that was our hypothesis. Maybe the discussion is challenging discussion. We keep on debating on that one, that I have a problem or I have pain when I'm in motion, whereas when x-rays and all these things are taken stationary. So how we can check on those two things there, and we put one hypothesis, and then we put later on we worked on that one, and that is basically we put sensors over the muscles like this one, and we ask the person to do some exercise, and we observe the signal strengths, and from the signal strengths we can identify that which muscle is getting weak. If any muscle is getting weak, our bones are connected like this, and these bones are then further supported by muscles. So if their muscles weakness is there, you can see there will be a deviation, and there is a tilt in the bone alignment, and maybe that is leading towards that leads towards pain and all those things. So that was the hypothesis, and to identify these things we have used machine learning and all. Drug discovery is another area. So you can see here, you just send the certain kind of inputs, and it will give an output. So I'm just sharing one of the conceptual. So there are a lot of approaches now being used in machine learning approaches being used. So genomes were taken, and then various combinations of chemicals taken, and then binding proteins and all those things are being done. Most of the job is done by the deep learning or machine learning algorithms. One of the interesting result was find by, you can see here, this algorithm is they have used just XGBoost, which is a ML algorithm. But this one is a result which is basically TMDU team they have put in. You can see here. So these are the various medicines which are being used. Alzheimer disease. But when you check it, then they check on the various aspects of it. What are the other effects? What are the stability? What can be the possible drug? What are the other issues related to it? And likewise. So the drug discovery is another domain where you can implement your machine learning. And this is Black Pearl. We did it long back, somewhere in 2008 and 9. That is controlling your machine, computer fully through a simple webcam. This we developed it for sensory integrated syndrome children, that how we can make things simpler for those SID children so that they can use computers. Human modeling is one part, and we have listened many stories. We have discussed with Kosinski work, and then later on Brexit and Cambridge Analytica. You just go through the story. We have also tried to do some kind of human modeling, and how it is being done is very easy. Like we have one image, and then from this image we put certain kind of algorithm to get the image of people who are in a certain kind of a dress arrangement, and then we put another method to find it out their time zones and all those things. And then from there, okay, we take certain feature, and the feature taken here is, okay, how many of them are or wearing the hat, that is basically protection cap there. And okay, you can say, okay, that person is an engineer. So this is identifying the things in a different way. This is a conceptual one. This is another one which we have later on got patent on this one also. This one is an inverter, which is a smart inverter. And the design of this inverter is inspired from this setup there. You can see the set, you can see here. So we know that before getting a heart attack, we have certain kind of a signature in our signals. So it's the same logic we have used it for this kind of inverter to be used here, which is PCC inverter. Inverter plays a point of common coupling. So we have this DC here, we have grid here, and here is the load. So this inverter works in two different modes. When the grid is connected, it works differently. When the grid is not connected, it works differently. So the job is how it can check it whether it grid is going off, and it automatically switch from one arrangement to another arrangement. And there we have used these algorithms to make it more intelligent. The another zone which is very interesting, worked on it, and and still it is really challenging, still working on this one. That is how your load can tell you that, okay, my capacity is gone. So just think of, you are using a refrigerator and it is smart one. You put a machine learning algorithm there, and it will send you a message that, gentlemen, okay, you are using me since last 10 years, and I'm cooling your things, but my power consumption, if you convert into the amount or money, so per month I'm consuming this much more, or this much more money you have to pay, if you continue to use me, then you have to pay this much more amount, or this is my quality, this is now my capacity, and likewise. That is basically the smart loads which are there. And then how those things can be put in the smart home kind of structure. Smart meter, which we have developed long back, and this has all facility. It track your behavior, how you are using the things at your home. It track what are the prices from the supplier side. It tracks the power quality of the things at your home, that, okay, how much is the active power, power factor, and all that. And not only that, it can manage the things at your home, that, okay, usually at 8 o'clock you listen to music, so then it passes signal and make your music device on at that time, kind of set up these things. There are a lot of benefit of doing these things, that the theft can be protected, power management, load management, human behavior, lot of things can be the agenda of research in this domain. This is the greenhouse. We worked, one of the scholar, Rahul, Dr. Rahul, he worked on this one. So the greenhouse was installed at that time. It was installed at Agriculture University Udaipur, and the data captured from there and the monitor and analyzed at Ramal at MNIT. So what are the data? So we put sensors and in the greenhouse, which give us the humidity, which give us the air, which give us the temperature, and then the actuators are there. So the calculations done, and then they send the signals back to the actuators to actuate it. Okay, how much more water to be put there, or what should be the airflow, so that the proper airflow can be done there. It can be taken at another level if you add more sensors, the quality of air. You put sensors to identify the component contents and the chemical components of the sand and all those things. So many more things can be done there, but this is the one of the example where we have implemented. Let me go a bit fast. We have done a lot in robotics. Okay, so this one is a reinforcement learning algorithm. We have implemented it in 2012. Yeah. So here the robo has to, and this robo has to avoid these obstacles and reach to the goal. So you can see here, we are not using any kind of proximity sensors and all that. You can see there are two cameras. These two cameras are used to make a human vision system. So two cameras give us the depth of the image, and then that image is help us in that understanding where is the object and how far it is, and then how it learned. It's not programmed that way. Mm, we what we did, we performed thousands and thousands of rounds. We left this bot, let it go. Once it hit it, we put a negative reward, put it uh, again here, and then let it go. And then next time it will take a small turn, again hit it, put it a negative reward, and likewise. So we have done more than hundred thousands of trials and all that, and then after that it learned automatically, and then we have seen that this sorry, I don't know whether it will work here. And this one is not playing, but yeah, it works very well. And then you can check more details on the Raman website. It is there, and the articles so are available to understand what is the methodology we have used, how we have incorporated CNN, reinforcement learning, cloud computing, distributed computing, and all those things there. This one is basically, you can see robotics part here. So you can see here, this one is half body, and the complexity is very high here. This one is complete leg movement. This will help in movement both this direction, this motor movement in these directions, knee movement, ankle movement, and likewise. I don't know why the videos are not working, but yeah, okay, you can check it from here. So you can see the movement here. It will exact our leg movement. You can see the bottom part goes there, and then the load transfer, and then the lift of the second leg, and likewise. The challenge here is this one is having, you can just think of how many motors are there, and it has to be stable also. So then how it will work, and all controllers and all those things are there. So it's a complex arrangement there, and we have used a certain kind of algorithms, machine learning algorithms to predict the trajectory, some algorithms to control the aspects of it, and many more things there. This one is another one which is currently we are working also. So we worked a lot on the drones. We developed the drones in the lab of our own. We have done a lot in racing drone. Now we are working on the swarm drones. You can see this one is kind of some kind of a demonstration done in the indoor environment. This one is manually operated, but this one is having camera which identify, we scan that, and this one is, I think it's before COVID. So it's a 6 years old video. The stability of this drone is very nice. It scan the images, send and then identify the things, send the signal to the base station, and then perform the further actions there. So lot of the combinations of the dynamics, real environment, and more other things can be done through this one. I'm just going a bit fast so that I finish the things in the time. Transport and e-mobility, we have done a case study there. I'll go straight forward to this case study. This is the case study done in the Jaipur. Okay, so this one is one of the road there. You can see the here. So this one is a straight road. Okay, so what we have done is we have merged three things. We have taken the Google APIs and then traffic APIs and then merged our algorithm. So you can see that this is the straight path, which is the shortest path. So if you move from this one is Patrika Gate, if you are aware of the Jaipur, and this one is the other end of that road. This is JLN Road, or which MNIT is also there. This is straight road. But what happened that during peak hours, the traffic is very high. And if I use this one in my objective that, okay, how I can save my petrol, so petrol or fuel, or if you can take another objective, how can save my time, and then we use these algorithms to give us the alternate solutions, trajectory planning algorithms. So here we tested it and we found that even though this red one is it's a big route, it's a longer route, but you can see that there is a 3% of fuel saving, even though the route is longer, because the traffic movement, the prediction of the traffic here is high, and you have to wait for a longer time on the red lights there. Though the red lights in this zone are more, but the duration, the waiting is less. So such kind of arrangements can be done, or such kind of issues can be solved by using these approaches. Okay, this one is now common everywhere, Alexa. So I'm not going to talk more on this one. I'm just talking to discuss one or two more issues, and then I'll stop it here. We have done a lot on medical application, and that is basically on like breast cancer histopathology, finding that particular image from tumor is benign or malignant. We have done a work on silicosis, so X-ray images, and to identify whether that person is suffering or not suffering, and if it is suffering, what is the grade of the silicosis. We have worked on the dental side. Right now I'm working here on brain scans for the effect on the brain of diabetes type 1, type 2, and the alternate solutions. And the this whole area is very open for AI people, that is medical applications. And then talk about some more application part. This one is another one which my another collaborator who worked on it, that is in retinopathology. So retina, and then from the retina, how to identify the image, and from there various issues can be identified. The another one is social media trends. You can work it that how the trends they are working and they are behaving. Then this domain is building very fast, and that is basically explainable AI. That okay, your models are giving some kind of output, but are they explainable? Explainable means why this model is giving that this is a tumor. So is there anything which indicate that this is the reason why, that's why this model has even this outcome. So this domain is certainly building up, and a lot of work is being done in this part. This one is health management system. So one of the scholar who worked on this one. This is another area where Dr. Surendra may discuss with you when during his lecture on this one. But this one is the experimental work he has done, that how the automated syringe that is invasive surgeries can be done, how this needle can be inserted smoothly into the body, avoiding the critical places, and then do the job at the right place. So it consists of lot of complexities. You can think of how complex is the problem, because there are tissues, different tissues are there for different person. There are inside there are some hard areas. The tumor or the thing or the jobs is to be done at a certain place, which is at a very complex place. Can we make this thing, or can we bring a technology which can smoothly move this needle to the correct place without disturbing the neighboring areas and likewise. So you can see a lot of applications are there. I'll just mention few of them which we have done. A lot of work is being done throughout throughout the world in different zones of engineering, medical, general science, or now you can see in law, you can see in history, you can geography. So you just think of the domain. So this one is basically, and this course is important that in a way that now you can't say that this is some certain thing which is related to computer science. No, this is must for everybody to understand it, how it works. Otherwise, there are certain kind of other things which are, you can say, unethical things are coming, and later on we may be in the trap of those things if we don't know this technology. Okay, these are the few references which I have used here for this presentation. Thank you very much. Thanks for listening me. Now I'm open for your questions. What we can do is I stop sharing it. I'll take your question. You write your queries in the chat box, or you unmute yourself and you can put your questions there. So I'm taking few of the questions are already there. I'm taking those questions. So understanding the data set, that was the question. First question, what do you mean by the understanding the data set? Understanding the data set means when you plot it, when you put it there, just check it. If I'm doing a simple, say I'm doing a classification, and if the data set are very placed in a way that they are easily separable, then why should I go for a complex model? I can use a very simple model to separate these two data. Or when I plot it, I'll find that there are many things which make no sense. They are not playing any role in the data points. That means what? There are many features which are meaningless. They are not playing that big role. Like I'm working, just one example, that I'm working on hospital data. And there is, when I collect the data in Excel sheet, I'll find that the name of a person is there. And when I hot encoded it and then I plot it, I'll find that the name of person is not that important for identifying a particular disease. So that data is not important for me. So just visualizing the things, you can directly remove it rather than going for some complex algorithms. That is where what I mean to understand the data. It may be possible my data is timestamp data. So if my data is timestamp data and I'm applying some approach which is an other way, I may end up with something wrong. I have seen few of the time that there are few algorithms which are dedicated or which are designed for timestamp data, but people are implementing those algorithms for a certain kind of a discrete data, which may give you sometimes some result, because there is a certain kind of a dependencies there, which because of that the results may be improved, but that is not a good way of doing this. That is what I mean here. Understand the data. The second question is applications in material science, nanomaterials. Yes. So yeah, Dr. Priya, the point here is, like we have seen one example of drug discovery. Same is the example there. Okay, I'm looking for a combination of material. to solve certain kind of or let's take a very simple example that for a high temperature uh, uh, device development of a high temperature device, I need a material. So I know the properties, I know the features, I know certain kind of material, but what is the best combination? So one way you do it manually or experimentally, but it take a lot of time and a lot of money also. Cost is very high. So best, the other way is you do it put these properties there, use machine learning algorithms, take out the combinations, put all the checkpoints, that stability and all those things, and then let your machine learning algorithm to identify some good combination, and then you try your experimental work directly on it, and that saves your time, that saves your money also. So such kind of applications are already there. The arrangements, the materials, the combinations, and the purpose for the purpose you are solving it. So that is one of the example. You can check on such kind of other methods or other challenges can be solved in material science. Okay, in the leg of ML, there are many types of learning. Yeah, so I have already shown you, Dr. Atul, that okay, there are applications. So if I'm working for a dynamic system, I told you, and there is a mechanism to get a feedback. So then I use reinforcement learning, because my environment is changing every time, it is giving me something new. So I use that kind of as input to learn. My model learn from the environment, and from there what I have developed is the algorithm which incorporate the dynamics into it, dynamics of the environment there. So if this type of job I want to solve, then okay, I go for the reinforcement learning. If I'm looking for a simple IIDs, my data are discrete data, and just I want to just classify the things, I can go for the classification kind of thing. And if they are labeled, then I'll go for the classifiers. If they are not labeled, I'll go for okay, let's make a cluster and then apply another level over it. So it depends upon what type of a problem you want to solve, and accordingly how we use the raw data, or we transform the data to another level to use certain kind of algorithm. So this is how you can choose your algorithm depending upon your application. Okay, let me take some more questions there. Yeah, so there is a question. One second. Yeah, in prediction model, is it necessary to know the output? See, and that is the point here. We can do a prediction even if we don't know the output. Don't know the output of everything. Let me give you one simple example. I'm doing one experiment in the lab. In the class, that okay, there are 10 students and I have to classify that who is fit, who is not fit. Okay. Or if this is the value, BMI, so body mass, what I'm doing is I'm measuring the height of a person, which is easy, and I'm measuring the weight. And then my job is to identify that whether the person is fit or not fit. It's a simple problem. So the one way of doing it is out of 10, for all the 10, I'll take all the 10% measurement and go to a doctor and show him that okay, these are the results, and you tell us which one is fit and which one is not fit. So I label all the 10, and then I use one algorithm just to map those two inputs and the output. This is the supervised way of doing the thing. So when the next time the 11th person will come, I'll put those parameters and I'll say that you are fit or you're not fit. But for this, I have to pay the doctor fee for 10% evaluation. The another way of doing it is, what I can do is I'll take measurement of all these 10 and cluster them into two groups. depending upon who are similar to which one. And then I'll take one sample from a group and go to a doctor that, okay, you tell me whether this person is fit or not fit. And he'll say that this one is fit. That means all the person in that group are likely to be more fit, and another group, they are less fit. So here I need only one input to do my things there. So there are approaches people are developing, and that is basically now the challenge is where people are working on. That is how we can go for accurate predictions for less data, less labeled data, and some other challenges there. That is how we need to do it. So it's not necessary to have all kind of values there, but it will be good. The model will be more accurate if you have more values, more data, more labels, and you are working on the prediction. But if you don't have, we have to think of alternate solutions, and there are certain alternate solutions. Okay. Okay, so there is another question is spike neural network. Spike neural network is basically more inspired from our neurons. So what neural network they are doing is, neural network, we give an input and we check the output. Brain never work that way. In brain, what is happening is signals goes in and then the signals comes out. Signal means there is a spike which goes in and then the operation occurs and then the spike goes out. So when you introduce this nature into a neural network, that is basically known as a spike neural network. And what is the benefit? The benefit is when you go for the hardware, if you make a simple neural network, you have to power up your inputs there. It will consume more power. But in spike neural network, you just send a spike which consumes a less power. So the power consumption wise, spike neural networks are very, very good. But the issues with the spike neural network is, while we activation functions and all those things which are continuous, you can take a derivative. But just think of the scenario when there are spike, how you take a derivatives. When there are things which are discontinuous in nature, and there are solutions. So spike neural network is more like a more towards the real human brain, a human neural system, and it's a good domain to work in. We have already published few articles on this one. You can go to website and check it there. There are a lot of things more can be added, like consciousness can be added, and spikes are two types, and then people talk about the depression and all those things there. So those things can be added there. This one is a good area to work on, but in a very simple way, this is what is there in the spike neural network. Okay, I'll take some more question here. Spike means weight or threshold. No. Spike means the input which is going. So input is never like a constant value. Like a neural network, I give input 1 and 2 and the output as 6. But in spike neural network, it is not 1. There is a representation of 1 in spikes, basically. That will goes in. And then output is also in the form of the spikes. Similarly, the activation functions and all those things, they are also different. So what you are saying, the threshold values and all these things, that will help us when whether the spike will be generated or not generated. So spike means that is how that the pulse is going in, and when they are added up. So what is neural network actually doing? It takes one signal, weighted one signal, weighted another signal, sum it up, pass through some kind of activation function, which decide whether the output should be generated or not generated. That's all. So now here in spike neural network, what will be there? The input which goes in, it is a spike or pulse train, you can say. And then when they summed up, there is a certain kind of, there are various methodology how you are summing them up. And then whether the output is generated, that will be decided by the threshold. how you are modifying that. That is all there in that is how you can separate out simple neural network and the spike neural network. Okay, just wait. I'll share you the link of websites so you can check it from there. Just wait, just wait. So this one is the lab website. You can take it from there. And this one is, I'll give you my website also. Some articles you can take it from there, which are available. Okay. Okay, I have given there. Okay, so I can see that no more questions in the chat box. But if you have other questions or you want to ask, you are most welcome. You can put it, you can type it there. Or if it's possible for you to unmute and speak, you can ask. If you have any more questions, what you can do is you can write a mail to me or mail to Dr. Surender, because we are working together at the lab is Raman Lab.
Yes.
Yeah, so you will know. Okay, should we know the coding for this FDP? Yes, coding will start. Next session is on coding. So first we prepare the basics, because many of the participants may not be that aware with Python. So today's session is more on the Python. I suggest everybody to participate there. I'll also attend it, because you do it, if you do it, you revise few things there. And from tomorrow onwards, there will be hands on the topics which we will discuss there. So like morning we are discussing on dysentery. Later in the during the evening you will do the hands-on. So we will have hands-on coding practices there. Okay. If you have questions right now, we are open. If you have questions later on, you have our mail ID. You just write a mail to that. Just request not to call on a phone. You can WhatsApp the message. We will reply you as and when we get the questions from your side. Okay, so there are applications in civil engineering. Yeah, civil engineering people are doing a lot, right from the material design, material for anything, to the structural design, to the management side, like to the pollution, environmental. I mean, you'll find applications everywhere. Right now, people are talking about that litter identification, automation, and all those things. So if you want to do automation anywhere, you need these approaches. Make it a kind of a thumb rule. If you want to do it automatic, you need machine learning or AI, because somebody has to identify those things. So say, I want to make a automated identification of litter, environmental issue, civil engineering issue. So then that means I need a machine learning which can methodal approach, which can identify whether this one is a litter or not a litter, likewise. So that's why it has application everywhere. Even people are using AI to solve some mathematical problems. And now you are using ChatGPT for everything. So it has a lot of applications. Yeah. So it has applications in civil engineering. Anything more? Okay, I think Dr. Surendra, I think there are no more questions for this session. So we can close this session and you can make the announcements for the next session. And like, thank you very much. Thanks everyone